Welcome back to Houdini Isn't Scary Project, Part 5, Rendering and Extras. So, this is the final part of the Houdini Isn't Scary Project series, and in this part we're just going over how to improve your scene, how to add some better functionality, how to go about setting up a render in Mantra or Karma, and where to go from here. So let's get straight into it. In Houdini we have this file where we left off last, and you can download this one below. This is the exact file from the download below. So the first thing I'm going to go do is make sure that my caches are referencing the right geometry file. Because when I attach this, I just said cache this somewhere because this would be a place on your computer, and so the reference that I had would give you an error. So let me go ahead and find these caches. So this would be the compress cache and the geometry cache. Right, so this is exactly what we ended with in the last tutorial. Where do we go from here? Well, there are a few improvements that we can make before we actually render this out properly. One of which is the actual quality of the simulation. So we can go over to our ball flip dynamics node and just go back to frame 45, or else it'll try to start simulating and you don't really want that. So go in here and onto your flip object, you have particle separation. So this particle separation of 0.005 is decent, and it's okay for a low resolution simulation, but we can actually halve it. Remember, lowering this increases the number of particles you have. So we're going to set that to 0.0025, so half of what it was. And you'll already see that there's more particles being put into this ball. The other thing that I noticed was some weird movement at the bottom of the simulation. And what was causing that was the slip scale on the viscosity tab. So go over to your flip solver, under volume motion, go over to your viscosity tab, and we have this slip on collision set to 0.8. Now, what this basically does is it stops your viscous fluids from sticking to surfaces, so they'll slip off. Now that's all well and good, but what ends up happening is it slips on the bottom as well. So to hide this, more or less, you can actually just drop this to about 0.6, and it won't be so noticeable at the bottom anymore. What you can do is you can use a control field, and I'm not going to go into this now because there is some complexity to it that isn't really necessary for a beginner tutorial. So we're just going to go back up once we're happy with our particle separation and our viscosity change. And then if we go over to our ball dynamics, we can recache this. So you'd click on this, you would just say save to disk. And I've done this before, and it gives me this cache high res. And I do the same over here. But there would be a few changes that I would also make on the particle fluid surface tab. Now, we have it set up over here as our particle separation. Remember, it's linked to our dynamics network, so this changes with it, which is awesome. We also have voxel scale, influence scale. Now, voxel scale will become a very familiar term when you start working with VDBs. Basically, it's the resolution of the volume that you're working with. Houdini converts your fields, so that's particles and volumes, in your particle fluid surface to a volume, and then it converts that volume to a geometry. Now the volume needs a voxel scale. And if we increase this voxel scale, it actually does a lot of smoothing. So we can push that up to 1 and then set our display flag on our particle fluid surface. And you'll notice that it does some smoothing. And now you'll also notice this weird geometry. This is because of adaptivity. Now adaptivity is over here. This is also something you'll see often on a convert VDB to polygons. Basically, when you're converting from a volume to a geometry, it has the option of limiting geometry by making large areas of weird shapes. So you can actually set this to 0 and you'll have quite a uniform geometry. You'll also have a lot of points. So if you don't want that, you can add adaptivity. If we go over to filtering, currently we have our smooth to mean curvature flow with a very high iteration count. We can change this to Gaussian. This is just the way that it calculates it. And 6 will be too high for Gaussian because you'll lose a lot of detail in the later frames. So if we take a look at this, you'll see that it's very much smoothed out. So you can drop that to 2. And what this gives you is a very smooth simulation. Now this might not be what you want every time, but this is something to keep in mind because this simulation, we do want a very smooth simulation. And so now I can just fetch that high res one that I created over here. As you can see, it's the exact same thing. So, this is what you end up with. It's very smooth. It's quite nice. When it's rendered out, you don't end up with any artifacts. So that's cool. Now, we have all of that. What else could we do? Well, we want to render this, but our render settings we haven't even touched on before. So let's go over to our camera, set it to camera 1, right? So now we're in this view, we can see what we want to render. If we go to our out network, so go over to OBJ, switch it to out, we have our render out node. And there's a bunch of settings on here, but I'm just going to go over what's important to us. If you go down here, you have these pixel samples, you have min ray samples, max ray samples, noise level, and then all of these over here. Now, all of these are very similar. These control single aspects of your shader. So, for example, you have diffuse quality. This is how much Mantra should focus on making sure that there's good quality diffuse. And then you have things like reflection. So if you have something that's, say, glass, you want to maybe push up your refraction quality because you want those areas to be cleaner and less noisy. But everything else can probably stay the same. Now, the main area to focus on is actually just until about noise level. These settings over here. So pixel samples, 3x3, the default's usually okay. That gives you decent looking results. Now, Mantra is a very slow renderer, keep that in mind. I would suggest rendering with either Karma or a different renderer, but you can adjust the noise level to about 0.03. What it does is general noise is not removed entirely, so it's a lot faster. And you can also drop your max ray samples to about 6. And with these settings, your rendering should be okay. Now, I'm not saying it's great, but your render times will be lower, and it's actually viable for somebody who's just doing this at home. And then you would just go to render frame range, you'd go over to your images, you would set an output picture. So the output picture, you can go and find a place to save it to. And in here, you could just call it mantra render dot $f, right? Because we want to save each frame. Dot. Now, if you intend on putting this together in After Effects or Nuke or Fusion, then go ahead and do the .exr sequence, right? So that would be this .exr. I save everything as .exr because it saves a lot of extra information that's extremely useful. And in studio work, you will pretty much always save as EXR. The alternative is you could save this as .png or .jpeg, and then what you could do is you could put it together in some other software like VLC, where they have the compile option, but Houdini, because it's a studio-based software, doesn't have the option to do something like .mov, right? Or .mpeg. You can't do those things. So you have to do $f, you save out an image sequence, .exr, right? I'll just do exr, accept, and then you say render to disk, and it'll start rendering each frame. So what I just showed you would be a perfectly reasonable way to render, but I also want to show you another option. This may get confusing, and the reason is because we're going to be using the Solaris Workflow. And this is something that has recently been added to Houdini, and it has a lot of complexity to it, but it enables you to do such amazing things. So I'm not exactly going to show you entirely how it works. I'm just going to show you for our particular scene how you could maybe use Karma to render, and so that you have that option open to you if you decide to do that. First thing we have to do is we have to change our desktop. So we change from this build that we have, and we've been working in build the entire time. We have to change it to Solaris. Right, this gives us some new panels over here. We still have our network view down here, our parameters up here, and our scene view over here. We just have these two new things over here. We have a scene graph tree and the scene graph details. Now, we change from our object level to our stage level, and that will empty your scene. The reason it empties your scene is because of the way stage works. You bring things onto this stage, you make changes to it on the stage, and then you can render the stage, which means that everything on your object level remains untouched, which is the amazing thing about this. It's non-destructive. You can make many different stages, and all of them can be referencing your object level, but not changing your object level. So you'll always have this exact setup on your object level, but you can have different setups on your stages. So the first thing we need to do is obviously bring in everything from our object level. To do that, we can use a scene import. So scene import all. And this brings everything in. And we can see this if we go to our camera, cam1, right? It even brings in our invisible collider. Now we need to define what we actually want to bring in. So we can go over to this object over here and change it. So we go over here and you can click to deselect everything. Holding Control, click on Background, All Dynamics, Platform, and all of your lights. We won't be selecting any of our setup nodes. We also won't be selecting our pipe and our camera for two different reasons, and I'll tell you why shortly. So we can accept those, and now we have this. Now, firstly, bringing your camera in from your scene view tends to not work great in this stage mode. And you can get it to work, but that will go into a bit of detail, and I don't really want to have to go into that right now. This isn't a Solaris tutorial. So all we'll do is just reposition, because our camera was very basic anyways. Control and click up here on this camera. This one is one specifically designed for LOPs. We're working now in LOPs, and those are just lighting operators, right? So now we have this new camera, and it has a bunch of settings on it, right? Not too confusing. Now what about our pipe? Well, the thing is, everything that we've brought in has its material on it. And the reason is because those materials were assigned on the actual nodes. If we go to our object level, our platform has it over here, material shader, our background, material background shader, our ball shader, but our pipe doesn't have anything. This was assigned inside of the node. So we have two groups for it, and we assign it there. Now, unfortunately, Solaris doesn't pick that up, and so we have to do it for it. So we import that separately, and we just drop down a SOP import node, and we can fetch a single node by selecting the SOP path. So bring in our pipe. And then we just have to tell it that we need these groups. So under the import data tab, we include subset groups. We'll just include both of our groups. Then we can merge this in with what exists. And there's our pipe. All we have to do now is just link the materials to it. And there's actually a node called a material linker. So material linker, and over here, you'll see it has some parameters. We can just expand our geometry, and we want our pipe. But you'll only see SOP import 1 over here. And that's because that's the name that it gives it by default. So all you have to do is just change this to be called pipe, and that's perfectly cool. And now you'll see it says pipe instead. So we expand pipe and mesh, and we have the glass pipe group and the pipe end group. That means we can just drag over our shaders. So the pipe group goes over to our glass pipe shader, and the pipe end shader to the pipe end group. And now we can actually take a look at how this would look as a comma render. You can click on perspective over here and change it from Houdini GL to comma beta. And just give it a second, and you'll see that we have this over here. Now, this is pretty cool because it's live rendering. So you can move around and take a look at this from different angles. And so they're still working on Karma, and I do believe that this will be a lot faster as they do work on it. But really it's in a pretty good place right now. So we can just go back to camera 1. If you want to render, it's quite simple. All you have to do is drop a Karma node. And the reason that I still teach people about Mantra is because Karma and Mantra look quite similar when you open them. You also have this render to disk, render to mplay, and resolution. Change the resolution. We can make this 4K if we want, or just 1920 by 1080. And we have a bunch of settings here as well. Now, if we go over to the rendering tab and we have sampling over here, this sampling is set to 128. Now, we can drop this quite low. We have a very simple scene, and so something like 12 is even fine. Even lower if you want. The other thing that we can do is go over to our images tab and use the optics denoiser. And this is one of the cool things about it. So if you go up to render, you can download the NVIDIA optics denoiser if you have a NVIDIA graphics card. And I think you have to have a fairly recent architecture, but you can check it out. There's information, I'll link it below. You can download the NVIDIA optics denoiser, and when you have it, you can enable the optics denoiser for Karma. What that does is it cleans up all of the noise. Now, in here, that looks quite weird. But when you do an actual render, it's really, really nice, because what you can do is clean up a lot of that fine noise that you can't really get rid of that would require much higher sampling. So you can do fairly low pixel samples and then clean it up with the optics denoiser. Now don't push this too far, because what ends up happening is the optics denoiser will cause artifacts if the image is too noisy. So you still have to have some sort of pixel sampling. So I'm going to show you a render that I did. It was only at about 8 samples, and I used the optics denoiser, right? So it was about 2.5 minutes per frame, and I'm going to show you what that looks like. And so here it is. You can take a look at that. And this was before I actually did the smoothing and all of that. But what you'll notice is that there's some artifacts. It looks almost like some wobbling. And that's the optics denoiser working on a very noisy image. So you can just increase your sampling and have a much better look for this. And then, just like before, all you would do is give it an output picture. So you call it something like comma render .$f.exr or .jpeg, whatever you want to use, but I'll use exr, accept, and then render to disk. All right, that's it. It's very similar to Mantra, but you have the option of, firstly viewing your viewport like this, and secondly of using the optics denoiser. And like I mentioned, what's really cool about this is if you go back to your object level, everything's unaffected. Right? Everything's still here, your camera is still here, everything is exactly as you left it. But now you have a stage, and you can make more stages if you want, but it's just really cool, because from here you could add lights if you wanted, you could apply different materials, and it's non-destructive, and you can have different stages and different iterations, and so that makes it really powerful. So yeah, I'm not going to go too in-depth here. This is just to show you an option that you do have. And then finally, back on our object level, I'm going to change this from Solaris back to build. I just want to show you some cool things that you can do once you're nearing the end of your project. So we have some settings that we may want to adjust, and they're all linked, but we haven't linked them per se. For example, frame 45 is when the ball impacts and turns into a fluid. But if we had to change our original RBD dynamic sim, that frame would change. And so how could we change all of the things that rely on that frame from one place? And so you can use what's called a controller, and you can just put it in any node, or you can make it its own node out here. What I'm going to do is I'm going to put it into the ball dynamics node, because this is basically the last node for it. And then I'm going to drop a null over to the side over here, and just call it controller, or whatever you want to call it. I'm going to press C to bring up colors, make it purple, press Z, and make it a circle, right? So now we have the little controller, and he looks different to all of our other nodes. So it's pretty cool. And as you can see, it has no parameters on it. But what's cool about Houdini is you can add parameters wherever you want. So we can go over here to this cog, click on it, edit parameter interface, and it'll bring this up. And this may look confusing, but all this is the parameters that show on this controller. So you can see that this copy input and cache input that are grayed out are these two over here under the root. So we can drag over something like an integer, right? Call it something like switch frame, and then give it a label so that it's easy to read, called switch frame as well. We can apply and accept that. And now we have this over here called switch frame. And at the moment it doesn't do anything, right? We can set that to 45. But now we can link this up with a copy relative references. Like we've done before, we can say copy parameter, and then go paste it in all the places that need it. So over here, we can just click on this, remove that greater than 44, and then say paste relative references. Right, so now if it's greater than 45, it used to be 44, but 45 is fine. And the other places that we can use that is if we go up a level for the start frame on our ball flip dynamics. We could paste it over here, paste relative references. Where else? Well, we can use it in our ball flip setup. Over here on our time shift node, we can paste it over here. Paste relative references. And now, if we had to change it on our controller to say 44 or 43, then you'll notice that it changes it everywhere. It changes it over here, and it changes it over here. So that's really cool, because then you can also link up other things like your particle separation. So back over to your controller, edit parameter interface, go ahead and drag over a float. Now the difference between a float and an integer is a float has decimal points. So that's useful for particle separation, which is like 0.0025, as opposed to frames, which will always be 1, 2, 3, 4, 5, 6, right? It'll always be a whole number. So now we can make this one called particle separation, give it a label, particle separation. And generally the name of these things would actually be something kind of like particle underscore separation, all lowercase. And then the label would be something human readable, like particle separation. You can apply and accept. And now you have this as well. And we want it to be 0.025. Oh, sorry, rather 0.0025. Then we can right click on it, copy parameter, and paste it into all the places we need it. So in our fluid compress, we can say paste relative reference. In our particle fluid surface, paste relative reference. And then in our ball flip dynamics network, we can paste relative references. So that's pretty cool, right? Because now everything is linked up and we can change it from a single controller over here. And this controller allows us to control our entire scene from just this single node, because we're changing important parameters from a single place. That's just an interesting thing that you can add to your scene when you're almost done with it. That really makes it feel a lot more user-friendly. And this is something that's really cool about Houdini, right? It allows the user to make it its own. You can make this your own. Like, you can make a controller for all sorts of things, and you can neaten things up the way that you'd like to, and you're not limited in any way. And so that's what's so amazing about Houdini. And I hope that this tutorial series has opened your mind to the possibilities firstly, and also showed you that although the appearance of Houdini is scary, if you take it bit by bit, step by step, it's not that bad. And sure, you know, end of the series, I'll admit, Houdini is kind of scary, but it's not scary when you understand it. And so getting to the point where you understand it is something that I hope I've helped you to do. And maybe now it's a lot less scary for you. Thank you for joining me on this adventure. This was really fun. I enjoyed making all of these tutorials, and your comments and interaction is amazing. If you have any comments, you can leave that down below. As for where the series is going, well, the Houdini Isn't Scary series will probably be back. We'll probably cover Pyro and Vellum and all of those things. But that'll be maybe in about 2 to 4 weeks. In between then, we'll be releasing some standalone tutorials that you can watch and follow along with. And from now on, I'll be including at the beginning of the tutorial whether it's something that a beginner could follow. So a beginner would be anyone who's maybe completed this series, or whether it's something a bit more difficult, in which case you could probably still follow along. But either way, I hope you stick around. We're going to be releasing a lot more content, and really the community looks great at the moment. And so a big thank you to all of you. Also a big thank you to all of our patrons. They have helped us so much, and the Patreon is growing, so that's cool. We can keep creating tutorials for free and keep committing time to it. So once again, thank you for watching. See you next time. Hopefully that is very soon. Until then, bye.